All right, so before we start actually working on these notes, so the notes start in the front where it says Day 4 Notes Radicals. We're going to actually go to the other side. The notes are kind of crazy, so we're going to take them out of order. We're going to actually take them in whatever order we need them to go in. I want to start, before I talk to you about roots and radicals, I want you to understand what all the vocabulary is. So when we talk about a radical, the radical sign is this check mark square root you guys are always talking about. I mean, I've heard you say the check mark square root. This is a square root. It's not always just a square root. So this one right here, the square root has an invisible 2 right there. I tried to make it as invisible as possible, but I went too crazy. So if you don't see anything, it's a 2 root. It's a square root. Any other time, if it's anything else, it's going to have the number on it. And what this means is, for a square root, I'm finding a number times itself. And so, like, for example, if I had 36, the square root of 36 is 6, because 6 times 6 is 36. If I look here at a cube root, in order for me to pull a number out from under the cube root, I'm looking for what times itself is that number. So, for example, 8 is 2 times 2 times 2. So the cube root of 8 is 2. Okay. Likewise, if I wanted to find the 6th root of something, I would have to have something times itself 6 times. 5 root, I'd have to have something times itself 5 times. This number here, we call that number the index, or the root. Again, if you don't see a number there, it's 2. But otherwise, it's going to have the number listed there, and that number is called the root. And that tells me how many times that number has to be multiplied by itself before I can pull it out from under the radical sign. The number under the radical sign we call the radicand. And the radicand is the number that I'm trying to find, so like, again, in this one, it was 36, which is the radicand. And when I talked about, the cube root of 8, 8 is the radicand. Now, sometimes you'll also have an exponent either inside or outside the parentheses when you're dealing with a radical as well. In that case, they're still called an exponent or a power. Okay? So, let's talk about that as well. So that's the parts of a root, the part of a radical. Okay, now let's go over here and let's talk about what that means to us. So I already did this example with you. So I'm looking for something times itself. So 36 is the square root of 6 times 6. And the square root of 6 times 6 means I have to have, so since it's an invisible 2 here, I have to have 2 of that, what times itself, before I can pull that number out, which means that the square root of 36 is 6. Now you know that one. That one's easy. Just like this one here, 100. The square root of 100 is the same thing as 10 times the square root of 10 times 10, which is 10, because I can take those two 10s, move them outside the radical sign, and they're worth 110. Okay? Now, those are easy, but then it gets a little harder when you see something like this. So if I were to put the square root of 27 in my calculator, I get this kind of craziness. Okay? So that's not going to help me. Right now, we're not talking about getting an exact value. We want to simplify square roots. So we're trying to find an equivalent answer, so without actually putting in our calculator. So what we do is we use prime factorization. And you don't always have to prime factor, because if you notice here, 6 and 6, they're not prime numbers. 10 is not a prime number. If I can find a number times itself, great. But if I can't, then I'm going to do prime factorization. So in this case, there's no number times itself that equals 27. So I know that 27 is 3 times 9, and 9 is 3 times 3. So the square root of 27 is the same thing as 3, square root of 3 times 3 times 3. Well, since this is a square root, I can only take out 2 at a time. So I have a 3 outside my root sign, and then I have another 3 inside. Does this one have a partner that I can take out with it? No, it does not, and because it doesn't, I have to leave my answer just like that. Now, when we put the square root of 27 in our calculator, we got 5.19, all that other stuff. Well, if I put 3 square root of 3 in my calculator, I get the same exact value. Because remember, simplify is a key word for finding equivalency. So if I simplify correctly, what I put in the calculator should be the same as, what I get at the end should be the same as the original. Okay? So let's look at the square root of 20. Okay, square root of 20. 20 is 5 times 4. 5 is prime. 4 is 2 times 2. And I'm done. So the square root of 20 is equivalent to the square root of 5 times 2 times 2. And then since this is a square root, I have to take them out 2 at a time. So I have 2 square root of 5. Does 5 have a partner? No, so I can't go any further. All right? I want to talk to you about negative 25 real quick. Now, and we're going to take a little detour in a moment. Actually, let's take that detour now. Well, let's talk about it now, and then we'll use this kind of as an example. So, if I want to find the square root of 25, I have to take negative 25. Take a number times itself. Well, 5 times 5 is positive 25. Negative 5 times negative 5 is positive 25. There is no square root of 25. Okay, so we're going to call this, what did I call this? I called this undefined. There's that flush again. Some of y'all are going to want to call this like 5 square root of negative 1. We're not doing that. That is a problem for a later math class. For now, we're going to call this undefined. Okay, so when can we take a root of a negative number? So let's just think about this. If I want to take the square root of 25, the square root of negative 25, I get error, non-real answer, so I can't do that. Now, what if I say negative 5 times negative 5 times negative 5? That's negative 125. Can I take the 3 root? Let me show you really quick how to do that in our whoopsie. No, that wasn't it either. In our calculator, you go to math, and if you see here, there's a 3 root, but there's also just an x root. And I can say, okay, what root do I want? Well, I want the 3 root of negative 125. Well, that worked. Okay? Let's try, just for the heck of it, let's try the 4 root of 125, of negative 125. It's not going to be, oh, non-real answer. Okay. Let's try the 5 root of negative 125. Okay, that's a weird number, but it works. So what are you noticing? Okay, so it worked. It didn't work on the 2 root, and the square root. It worked on the 3. It didn't work on the 4. It worked on the 5. What is the pattern with those numbers? What is the pattern that you see about those numbers? Well, what I see, and let's look over here. I'm going to write this right here. What I see is that I can take the root of a negative number when the index is odd, meaning not divisible by 2. And when did it not work? It didn't work when it was a 4 or a 2, well, you know, the invisible 2. It didn't work when it was even. So if the index is odd, I can take the root of a negative number. If the index is even, I cannot take the root. I can't find a root of that number. So a square root, a 4 root, a 6 root, an 8 root, I can't take a negative, find the negative root. But I can if it's an odd number. Okay? So that's why it doesn't work here. All right, I want you to do these 4 problems and bring them to class with you tomorrow. And then I want you to write down the word buttercup. Okay? Write down the word buttercup. So 1, 2, 3, 4, these problems and the word buttercup. All right, so let's go down here and let's look at this problem right here, okay? All right, so for this one, can I take the root of these? Okay, well, the 4 root of 16. Okay, so how many do I need? How many of the same factor do I need to be able to take the root of this, an even root? I need 4. So 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Okay? So the 4 root of 16 is the same thing as the 4 root of 2 times 2 times 2 times 2. There's 4 2's, and I exchange them for 1 2 on the outside of my radical sign. So the answer here is 2. Now what about this, negative 243? Just for the heck of it, let's put this in our calculator and see if we can get, let's just get this here. Do I have a 5 root? Yay, okay. And I'm going to do negative 243. That worked. It's negative 3. Okay? Now, and we'll save these for another time. Okay, so again, the point is, if I have a even number, if I have an even index and a negative under the radical, it's undefined. If I have an odd index and a negative under the radical, I can take the root of that number. Now that doesn't mean that that root is going to be any good. Y'all already have your quiz? Okay, but it does mean that I can take the root of it. It may be like some weird decimal. Sorry about that interruption, but it does mean that I can get the root of it. Okay, so let's go over to the other side. So that's radicals. Okay, and that's how we're going to do radicals. All right, anything left over stays under the radical. I take them out in pairs. All right, now let's look over here at rational exponents. Okay, so they've already put square root of 16 in the calculator and they got 4. Okay, now I'm going to put this in the calculator and see what I get. 16 to the alpha y equals 1/2. I get 4. So 16 to the 1/2 is 4. 64 is 8. The square root of 64 is 8. And 64 to the 1/2 is also 8. Square root of 81 is 9. 81 to the 1/2. What do we think 81 to the 1/2 is going to be? Well, let's find out. 81 to the 1/2 is 9. Okay? So what I'm seeing is that these are equivalent and they are somehow linked to each other. Okay? So let's look at some other examples. Let's look at these other examples and see if we can figure it out. Okay? So let's think about this. What is the invisible exponent on every one of these? Hopefully you're saying that this is 16 to the first, 64 to the first, 81 to the first. What's the invisible index on this square root sign? What did I say? If you don't see anything, what is it? Well, if you don't remember, it's 2. Okay? So I see square root of 16 is 4. 16 to the 1/2, 1/2, 1/2, 1/2. Let's look at this one. What would I write this one as? Well, this is an invisible exponent of 1. So that'll be 32 to the 1/4. So I put the exponent over the index. Okay? Let's try this one. We're going to put the exponent over the index. So it's going to be 243 to the 1/5. Okay? So likewise, if I look at this, what am I going to see? Okay? Well, I have 32. So what I'm ending up with is, Radicand to the exponent. So if I have that, the radicand raised to an exponent with the index on the outside is to the exponent over the index. Okay, so these are equivalent, and we're going to write something that's not this crazy. Okay, so now for this one, that means the exponent is 1. And the index is 4. So I'm looking for the 4 root of 32. Look, they're the exact same thing. For this one, I have under the radical sign, I have 243. Its invisible exponent is 1. Its index is 5. Okay? Let's try one that's a little harder. Let's look at this one here. Let me zoom in a little bit because these are some kind of tiny numbers. Let's try this one. Okay? Okay, so for this one, if I write this using that format, okay, so I have radicand to the exponent and index. So I'm going to do negative 27 to the exponent, which is 2, over index, which is 3. And if I put that in the calculator, well, let me zoom back out again. Okay, if I put that in the calculator, and I put the 3 root of parentheses, negative 27 squared, I get that number. I get that number there. If I put negative 27 raised to the 2/3 power, what? I'm sorry. Did I do something wrong on that one? Oh yeah, I did that. I'm sorry, that one was completely wrong. I feel like a ding dong. Let me fix that. This should be squared. Okay, so I get 9 for both of them. Oopsie, sorry about that. Just pretend that didn't happen. Okay, but if you see, when I actually put them in the calculator right, I get the same thing. Okay, and they both equal 9. Okay, I want you, well, we're not going to do anything with those right now. I'm going to actually have you do these practice problems down here. So again, the summary is, okay, 8 to the m over n is the n root of a to the m. Okay, and that's, if I had my formula chart, which I do, just give me a second, I have my formula chart. I believe that see the formula right here, that's what it looks like on the formula chart. If you look right here, a to the m over n equals the n root of a to the m. And I'm not really sure, honestly, what this is, okay? And then here, a to the m over n, m is the exponent, and n is the index. And we're going to write this stuff, we're going to write all this stuff, like specifically this stuff, we're going to label all the parts of a radical and everything, we're going to, and the fractional exponent, we're going to label all that stuff and put it in the in your notes tomorrow, okay? So let's try one. Okay, so the square root of 42. I'm going to write all my invisibles and rewrite it. I'm just writing it in a fractional exponent. I'm not solving it right now. That's 42 to the 1/2. Okay, let me zoom in a little bit. All right. Now for this one obviously they want me to go in the other direction. Okay, so that would be, I'm going to make my radical. I'm going to put negative 27 in it. It's got a 1 exponent and a 3 index. Okay. 32 to the 3rd. I write down, this is going to be my base. So the radicand is my base. The exponent is on the top, and the index is on the bottom. And that's an exponent. That is not just a times 3/5. It's an exponent. Okay? I want you to try these. All I want you to do with these, I don't want you to get them down to a final number. All I want you to do with these is write them in fractional exponent form. So I want you to write them in this form. Okay? And then I want you to write down the word rutabaga. Okay? All right, so for you guys to do tonight, you're going to do the buttercup section, square root of 50, 28, square root of 28, square root of 63, square root of 32, square root of 32, buttercup, and you're going to do the rutabaga section, which is these practice problems down here at the very bottom, the rutabaga section. Okay? Yeah, if I can find the recording button, I will see y'all tomorrow. Have a good day.